This is going to be a video to help you get an idea of our next lab, which will be finding the relationship between distance and time. So, here is what you'll have for equipment. You have a toy car. And there it goes. Tape, a stopwatch, and a meter stick. Your job will be to figure out the relationship between the distance the car goes and how long it takes the car to get there. All right. Hello. We're back. And this is Mr. Densmore right here, other physics teacher. We're in the hallway, and we've got to figure out a way to measure the distance that this car will move, so that way we know when to start and stop our stopwatch. And there are plenty of different ways we could do it. I think Mr. Densmore and I are going to sit down and think about it for a second, and when we come back, you'll see what we decided to do. How can we do this?
So we can either measure out distance.
Here's 10 meter. Oh, that's 10 meters.
Oh, we gotta. Oh, well, I think that looks nice, but for me, I think I'm gonna want my students to use the meter stick because you have to be really precise and accurate if you use the meter stick. It's a lot harder, and we're honors students here.
So we can measure out a set distance,
okay,
whether it's 1 meter or 2 meters, and put a mark of tape at each increment.
Okay.
That's one option.
That's a good idea.
Or we could measure a start and a finish line.
A start and a finish line. Okay. And then
start the car and put a piece of tape down every 2 or 3 seconds.
Oh, so we could have increments.
We could have time increments between a start and finish line, or we could have set distance increments.
Okay. Or we could just have one full distance and measure it once and then change the distance and measure it again.
Yes.
That seems like a lot of work too. I like how we can just continue to put a mark down every 2 seconds and we know how far the car went every 2 seconds.
Right.
And I also like the idea of putting down a bunch of different measurements, maybe like measuring a meter. By every meter we put a piece of tape, and then we can kind of time how long it takes the car to go from the starting point to the first meter line. Yeah, and then how long it'd take the car to go from the starting point to the second meter line, and then we'll do it again for how long it takes to the third meter line.
So there's lots of ways to do it. I don't think there's one best way to do it, but you decide which way you think is best.
Okay.
Yeah, I think that's good.
All right, I'll Rochambeau you for it. Sure. All right, so after careful consideration, Mr. Densmore and I decided we were going to do it
2 ways.
Both ways. Both ways that we could figure out. 2 ways. One where we have increments of 1 meter, and the meter goes from the beginning of the tape here to the beginning of the tape here. It's really important to make sure exactly how long the meter is. So as soon as the car begins to cross the blue line, we start the timer, and as soon as the car begins to cross this one, we stop the timer. And keep in mind, human reaction time is about 0.2 seconds. So that means that there's going to be a little error involved just because we're human and our reaction times are not instantaneous. So when we say go, there's a 0.2 second delay. Okay, so let me see. Mr. Densmore, what do you think? Should we start it right there, or should we start it a little back?
Yeah.
So that way I can...
have a lead in?
Yeah, that way I can do better with my human reaction time.
That works.
Okay, you ready? Let's do it. Yes, sir. Okay, so I'm going to start it right when the car...
Here we go.
Yes, sir. Ready to go. And start. And stop. Okay. Awesome. Here, let's try that one more time. I don't think my human reaction time was on, so...
We can use this split function on the...
Oh, yeah.
Well.
Yeah.
That's another option.
Okay,
All right,
here we go.
Here
Yes,
we
sir.
go.
Ready? Okay, and go. And, okay, I got 2.19 seconds per 1 meter. And then if we wanted to, we could do that again to the 2 meter line. Then if we wanted to, after that, we could do that to the 3 meter line, and so forth and so on, to get 6, 7, 8 data points, because that's how much we need to actually have a clear line. Okay, so we're going to do that, and then we'll come back and do the other method. Sound good? All right.
All right, so here we are. We're going to do the other method now, which involves...
Putting a piece of tape down every 2 seconds, right, Mr. T?
That's right. So we got we got a preset course that's 10 meters long.
10 meters long, right, from that line all the way to that one over there.
Down, all the way down to the other end of the hall. And what we're going to do, Mr. Martin is going to put a piece of tape down on the floor every 2 seconds. So I'll have the stopwatch, and I'll let him know every 2 seconds, and he'll put a piece down right where the car is at that moment.
Okay, so then we'll know that from there to there will be two seconds.
2 seconds.
And then we'll know the distance and the time, so that'll still be a data point, right?
Exactly.
And then from there to the next one will be 4 seconds. I think I understand.
Yep.
Oh yeah, this seems. I feel like it's going to be a little imprecise, but we're also human, so we'll just do what we can.
That's right. This one is tricky. All right.
You tell me when you're ready, Mr. T.
Okay. Go ahead.
Okay, here we go. Ready with my first one.
And start. Oh, it didn't work.
It didn't work.
Darn it.
Okay. Little human reaction. Let's try again.
Wrong button. All right.
Ready?
Go for it.
Okay. You tell me.
Okay. 2. 2. 2. 2. 2. 2.
All right, I think that's going to be it.
All right, the car is crashed.
Car's fast.
So, as you can see, this method is a little more difficult, but it still serves the purpose. And we can still get some pretty good data from this.
So now I guess, Mr. T, we're just going to measure from here to here for the first one. That'll be 2 seconds.
That'll be 1 data point.
And then we could just measure from here to here, and then add on that, and we can say that was
Correct.
4.
Right.
And then I can measure from here to here, then add on that I already measured for 6 seconds.
Mm-hmm.
And then from here to here, add on all that for 8
For
seconds,
8.
and so forth and so on.
Yep.
And after that, we'll get enough data points to make a good graph, right?
Exactly.
And then if we really want to have a good one, we could do multiple runs, right?
Absolutely. Yeah. Always a good thought. Do multiple runs. The other option, if 2 seconds is a little much, you can extend it. Make it 3 seconds.
Ooh,
sometimes
that's
it's
a
a
good
little
idea.
difficult to get the tape down quickly.
Yeah, you had me working. Mr. T. I think I broke a sweat. All right.
All right.
Anything else you think they need to know?
I think they can figure it out. They're honors.
Touche.
All right.
Touche. Oh my gosh, I think we got it. Did we get it?
Yeah, we got some
Okay.
good data. We're
Oh,
all
look, there's a piece of tape. Let's make sure we get that one too. Yeah, that was some good work. I think we got some great data points.
set. We did.
And then I guess the next thing to do is just going to be to graph it.
Yeah, take a look at the data. Put it in the graph.
Sure, put everything away here. There we go.
In here.
Yep, and then we can just put this right here for now. So we're just going to graph it, put it, which should be on the X and which should be on the Y.
Well, the distance should be on the y-axis.
Oh, is that because time is if we have time, it's always on the X?
Absolutely.
Oh yeah, that's right. So time is always our independent variable because we can't really control it,
Exactly.
right? So
Yep.
we just kind of see what happens with the time. So time is always on the X if we have time, and then distance is going to be on the Y because that's the only other place to put it.
Yep.
Right, because,
Yeah.
okay, cool. And then we just make a best fit line like this one over here. Yeah, plot the points, and then the best fit line, which is the happy medium. And Mr. T, if the time is 0, how far have we gone?
0.
Okay, so if the time is 0, then we've gone 0. That makes me think that we should have the best fit line go through the 0, 0 mark, because if there's no time, there's no distance. It's just the same as with if there's no diameter, there's no circumference. So that makes perfect sense for us to put our best fit line through the 0, 0 mark again. We'll find the happy medium, then we'll use the equation of the line y equals mx plus b, and then we should be good to go. Yeah?
Okay, I think we'll be all set.
All right, I'm looking forward to see how the data turns out. All right, Mr. T, thanks for the work. You man.
Yeah.
Rock on.